So in this problem, we have x, y, and z. These are given by three geometric series. We need to show that x, y over z equals ab over c. So let's begin. We'll start with our first geometric series. So here we have x equals to a plus a over r plus a over r squared, and it sums up to infinity. We know that sum to infinity of a geometric progression is given by a over 1 minus r. So here a represents the first term and r is the common ratio. Then again, the first term, that's a, the common ratio r, so that's the second term a over r divided by the first term, so that means multiplying it with the reciprocal of the first term, and this is going to give us a value 1 over r. So we can apply the sum. So x will then be equals to the first term a divided by 1 minus the common ratio, that's 1 over r, which means x will be equals to a times r divided by r minus 1. So let's label this as number 1. Then we have given y given by another geometric series. We have b minus b over r plus b over r squared, and it sums up to infinity. So here the first term a, so that's equals to b, the common ratio r, that's equals to, so we have negative b over r divided by b, so that means multiply to the reciprocal of the first term, so that's negative 1 over r. So we can find out the sum. So ry will be equals to the first term, which is b, divided by 1 minus the common ratio, so we have negative 1 over r, so we'll get 1 over r. So y will be equals to b times r divided by r plus 1. Next, we have z, which is given by c plus c over r squared plus c over r raised to the power of 4, summing up to infinity. So z will be equals to the first term, which is c, divided by 1 minus the common ratio. So common ratio will be c over r squared divided by c, which is 1 over r squared. So z value will be equals to c times r squared divided by r squared minus 1. So we have obtained the value of x, y, and z in terms of the geometric series. Now what we'll do, we will start from the left hand side. So we'll take the product of x and y and divide it by z. So let's do that. So x times y divided by z. So x value, that's a multiplied to r divided by r minus 1, multiplied to y, which is b times r divided by r plus 1, all divided by z. So z value, that's cr squared. We have c r squared divided by r squared minus 1. So this can be also simplified as a times b times r squared, whole divided by, so r minus 1 times r plus 1, so that's r squared minus 1, whole thing divided by c times r squared divided by r squared minus 1. So here r squared and r squared minus 1 will get cancelled, and this is going to leave us with a b over c. So hence we have successfully showed that x, y over z, that's equals to ab over c, hence proved.